almost in.
Okay. Sorry for the... We are seeing your screen, correct?
Okay, that's...
Okay.
Installed again. Well, welcome also from Delft. I hope it works now. My topic today is self-healing concrete and asphalt. It's quite strange to give a seminar like this just in my office behind my computer, but I will do my best. My name is Schlangen. I did this work together with many of my colleagues in the micro lab at Delft University. And if you want to read more about the work we are doing, you can look at our websites, self-healing asphalt and self-healing concrete, where our projects are described that we are doing. The outline of the talk today is first some background about self-healing. Then I will talk a little bit about the Rilem healing concrete and some examples of the research that people are doing in this committee. Then I will present some different self-healing projects that we do in Delft, and I will end with some conclusions and future research. And after that we will try to answer all your questions that you still have. Well, if you mix concrete, we all know how that works. You need some solid parts, cement, sand and gravel. You add some liquid to it, and then you mix it and you get concrete. And you know that all the properties that we get, we can estimate it if we do it in this simple way. But nowadays we try to make a much better concrete with much higher performance and longer service life. So we add much more additives to the concrete. We add fine particles, fillers, fibers, all sort of chemicals, just to make the concrete better, to have a higher performance and a longer service life. This performance in time you can plot in a graph like shown here. So on the vertical axis you have the performance, on the horizontal axis you have the time, and you see a certain threshold that you should meet. If your performance is above that threshold, you have a good concrete. And but at a certain time the performance will go down, and then you have to replace your material. Tail back after some time. And also here we know our body can repair small scratches, small cracks in the material. Our blood is able to do that to get a healed material again. And sometimes you see that people cut off parts of the body of a person, and then after some time it's healed again. So there are also some magic involved to get this self-healing. Well, then to the self-healing committee of Rilem TC 221, which is dealing with concrete. You see here a list of people that are working in this committee, people from all over the world. They're all investigating self-healing and trying to do research on this topic to create materials, concrete, that can heal themselves. So in this committee we try to discuss all these different methods and try to make a state-of-the-art report where everything is described. And it is a tunnel wall or a basement wall. This is an example of material that is mainly developed at the University of Michigan by a group of Victor Lee, called ECC, Engineered Cementitious Composites. It's a material that we also try to make here in Delft. We have a specimen here. I can try to hold it for the webcam. As you see, you can break the material. That's what happens now. But it's also a bendable material, so you can bend it and you get a lot of micro cracks in the material. And if you bend it too far, you will see that it really breaks what happened just with the specimen before. So this material has already some requirements in it to get good self-healing. Because if you bend it, you get a lot of small micro cracks in the material. These close cracks in the material. So the idea is that you have a concrete like this. Here you see the reinforcement and the crack running up to the reinforcement. And we put bacteria inside some spherical particles, some lightweight particles. We also add some food, in this case calcium lactate. That's something the bacteria really like. And then if you get water penetrating into the crack, these bacteria start to multiply very fast, and they are starting to convert the food and some
I'll be gone.